Has everybody enjoyed the conference? Yeah? So I think, before I begin, I want everybody to give a huge round of applause to DevOps Barcelona staff and organization crew. Come on. So thank you very much for staying so late. I know I'm the one thing between you and your beer this evening, so I'll try to be brief. But I'm Nic Jackson. I work as a developer advocate at HashiCorp. That's me. And yeah, I tried to train a crow to fly once. This crow, called Jon Snow. Yeah. As it turns out, training a crow to fly when you're not a crow hopefully is a little bit harder than my demo today. Anyway, so what I want to talk to you about is HashiCorp Vault. But I want to talk to you about HashiCorp Vault in terms of application security. So what I want to look at is the threats which are placed upon modern applications, and I want to look at how Vault can help them. So kind of the concept behind this is that we're building different systems. We're at a conference, we're talking about microservices. We're talking about serverless maybe even next year, but the fact is that systems are different. 5 years ago, we might have been building monoliths, we might have been running in private data centers, but we're not doing that now. So the way that we build systems means that we have to think about the way that we secure those systems as well. We've got things and components which are far beyond that single sort of monolith and database. We don't have control over the network. What it means for you as an operations person or as an application developer is that you can't take the same approach that you used to do. You can't take that Castle and Moat approach. You can't assume that your application is safe because you've got a crocodile-filled moat surrounding your castle walls. And also, why is that important? So, you know, you can get this data online. You can look at reports from Symantec. You can look at a number of different sources, and the one thing that you're going to see is that the number of threats or attacks that are happening on a system is going up and up and up and up every year. Like last week or something, there was the DDoS on GitHub, something like 1.2 terabytes. That was like far, far bigger than the biggest attack, which was Mirrorbotnet, which happened like 12 months ago or something. Attackers are getting more sophisticated, computers are getting more complicated, applications are getting more complicated. And I want to talk about point 3. So I think this is really interesting. So I stole this quote, like all good quotes should be stolen. But I think this is something that I'm going to come back to time and time again, in that it might not be the application which is compromised which does you the damage. So where do we look when we start to think about application threats? And I think a good place to start is always OWASP. I think OWASP produce some really, really good information. They produce some really, really high-quality material. So let's have a look at the OWASP top 10. So I can't tell you I've got a solution to all of these, but I think for the solutions that I do have, it's good to take a rough overview of these application threats. So injection, little Bobby drop tables, anybody aware of little Bobby? Number 1 on the OWASP top 10, I think it's been there for like 5 years or something. So, executing remote SQL injection attacks, LDAP injection. It's when an attacker is going to send that hostile data and make your system do something it wasn't intended. And then you've got broken authentication. I mean, this is actually quite hard, but I mean, number 2 on the OWASP top 10. And it sort of takes a number of different forms, but at a concept, it's about an attacker gaining access to your system, right? So they're going to do things like brute forcing a login. They're going to do things like using password lists, which are harvested from leaked sources. They may even going to use things like default usernames and passwords. Nobody does that right. But there's also things like using flaws and session tokens. And this is something that's becoming more common as well. So rather than sort of going directly at the sort of the cryptographically secure data, because that is intensive. One of the things that the attackers are doing is they're looking at just stealing plain text data that you've left lying around on your server. XML processing. Nobody uses XML anymore, but you do. I mean, one of the big vulnerabilities around this was image tragic. It was when there was a vulnerability in PostScript. And of course, broken access control. Maybe you haven't got the correct sort of authorization. You're leaving yourself open to confuse deputy. Or maybe your tokenization that you're using to secure your systems is not up to scratch. This one's number 6, in security misconfiguration. OWASP reckons this is one of the most common issues that they see. And it is things like not setting the right permissions on cloud storage, not removing default usernames. Cross-site scripting. This is a fairly well-known one, fairly well sort of exploited. Injecting JavaScript into web forms. And I think this one, insecure deserialization, is something that's really, really relevant to the world of microservices. Because I don't think insecure deserialization is just about remote code injection, but I think it's also about injecting messages into things like message queues and making a system do something that it doesn't want to. Vulnerabilities in libraries. There's a CVE database. There's always a case when you're not updating your application, but we should always try to keep things patched. Recent vulnerabilities in struts and JavaScript have shown us. And I think this is an interesting one because while logging's not really going to stop a threat, what it is going to do is going to detect you if there's been a breach. So back to that quote, and dispelling a myth about Hollywood, an attack on your system isn't necessarily going to happen in the moment. It's something which is potentially going to take place over time. An attacker needs to move through your system, and having the correct levels of monitoring and logging may let you catch that before any damage is done. All right, so we've looked at the system, we've looked at the problems. This is a Vault talk. Why have I not talked about Vault? So let's do that. Disclaimer, can't cover every issue. It's not going to magically fix all of your issues. But Vault's designed to cover a few different things. Eliminate secret sprawl. It's designed to help you store secrets, and it implements like a way of giving you governance and policy control over your secrets. And when we look at those policies, this is kind of like the core thing in Vault. So you have a policy, and a policy controls what a user can do and to what. It's very fine-grained, but it gives you that complete control. You can, for example, create a private key in Vault, and you can define different users' read access or use of that key. Authentication, obviously, in order to use policy, you have to authenticate against Vault. And Vault supports a number of different authentication methods. So you've got things like AWS, GitHub Authentication, Google Cloud, Kubernetes, LDAP, Okta, Radius servers. It's pretty comprehensive, and you've also got the capability to build your own plugins. So the process is that you log into Vault. You get a Vault token. And this could be an application or an individual. And then you can use that token to perform various actions. You can obtain static secrets. You can obtain dynamic secrets. And we'll look at those. And again, on the security, everything is encrypted at rest. It uses ciphertext wrapping. Everything is secure. It's stored. It's trusted by a huge number of people. And we're really proud of that. How does it work? So it runs as a server. So in this example here, I've got Vault configured to use a console backend. So Vault needs a data store. It doesn't have a data store of its own. In a high availability mode, you have a single server which is active. And in this example, 2 hot passives. In terms of what you can use for the storage backend, you don't just need to use console. You've got a whole bunch of things, DynamoD, MySQL, Cassandra, and again, write your own plugin if you want to. But I think it can help us in the modern world. And these are the things that I'm looking at. So I look at the OWASP threats, broken authentication. What are the things that Vault can help with? So things like dynamic credentials, one-time passwords. Use the transit backend for hashing and signing messages. And on that one-time password, I think we bring it back to what I was talking about in the beginning. It might not be your system that's insecure. You might have really great password security on your system. But look at these numbers. I mean, like, how many, this is on just have I been pawned, but how many accounts have been leaked into the internet? Like nearly 5 billion. And if your site's not one of those, like, why care, right? Well, you should care because the problem is that users will tend to use the same password. So the password you use on one website might be the same that you use on another. I know the best practice is we should change them, but we're humans. We make mistakes. And one of the simplest ways that you can mitigate against your website from being used against one of these password lists is that you can implement one-time passwords. So two-factor authentication. Vault's got the capability to act as both a two-factor generator, but also a provider. And I'm going to do a demo of how easy that is to use, hopefully. Demo gods. Demo time. That's not the screen you want to be seeing. Okay, so this is really awkward for me on a number of levels. One, because I'm a little bit too tall to be bending over this thing, but so when we want to use one-time passwords in Vault, the first thing that we've got to do is we've got to enable the one-time password secret backend. So we enable that. The next thing that we need to do is we just need to set up a user. Now, I'm showing you this through the CLI, but you can do everything through the API or other methods. But let's have a look at this, how you would do it through the CLI. So I'm going to generate a new setting for a user@domain.com. And what that gives me back is it gives me back a base64 encoded barcode that I can use to let people scan. And it also gives me back a URL that you can use with a generator. So let's have a quick look. And if I can find my mouse. Oh, there we go. I'm trying to move things across screens. I can't find my web browser. Oh. So we've got 3 screens set up here. Unfortunately, the one I want it on is the one down there. And to get to that, I can't actually see my mouse to move it across. So I'll tell you what I'm going to do. I'm going to continue. You can trust me on that. So number 3 on the OWASP list is about stealing data, so sensitive data exposure. So we mentioned that, like, rather than trying to break cryptography, which is quite difficult, rather than trying to work out how to get your brute force your passwords, I can just steal a password list. This is important because of GDPR. I mean, GDPR affects everyone. It's not just affecting Europe, it affects everybody who deals with Europe. And the penalties can be really, really harsh. I mean, up to like 20 million euros or probably like 100 million British pounds by next year. But these are the 3 areas which are generally the most vulnerable. So you've got things like data stored in plain text. You've got weak key management. You've got data in transit, so non-secured connections, plain HTTP inside your server. And looking at that, I mean, in addition to the 5 billion passwords, you can download a database from a torrent which contains 1.4 billion usernames. Yeah, exactly, right? 1.4 billion usernames and passwords in plain text that you can use to attack a login. Now, this is awesome. This is really, really positive, right? I think we should have a big cheer that password is no longer the #1 password. Yeah, that wasn't a big cheer. However, like 10 million people think this is okay. And you're not worried about securing your data and keeping things safe with 2FA? But realistically, I mean, it's not impossible, but it's relatively possible to break cryptography. If you don't use the right strengths, if you can use GPU accelerated taps. If you haven't got the right salting on your hashes, you can use rainbow tables. But it's not easy. I mean, you need to do it, but it's not easy. But thankfully, Vault's got the transit secret engine. And what this allows you to do is to do things like sign messages, allows you to sign data, allows you to perform hashing, allows you to generate keys. And you don't need to worry so much about whether you're using the algorithms right, because Vault can do it for you. Oh, God. Oh, no, it's okay. I'm doing all of this in the terminal. It's fine. Thank you. So again, like all of the things in Vault, what you have to do is you have to enable each of these engines individually. So let's just enable the transit secret engine. And then what we're going to do is we're going to create a new key. So I'm going to HMAC something. So I'm going to create a key because an HMAC is a combination of private key and cryptographic hash. And Vault's got the capability to rotate keys, so you don't have to worry too much about that. You can manage multiple active keys at once and then slowly transition things over. So I create a key. And then what I can do is I can use the Vault API to be able to hash some data. So for example, wrong one. I thought I was being really clever by putting this all into my reverse shell, and I'm not. So I'm going to have to type it, because I can't even get it from my browser anymore. There we go. So I can use the API backend. I'm HMACing the string hello world. Because it's a hash, see, I'm going to get the same thing back every time. Nice and easy. So what's next on the hit list? Well, not that. But we have this. So we mentioned about plain text. We mentioned about defending the castle, right? So you have an approach where you implicitly trust everything that's inside your castle walls. But you've got to think about an approach like this. So if you have a hostile actor, now that hostile actor could execute a remote code execution on a completely unrelated service. But what that would allow them to do is to start sniffing some traffic. So I start sniffing some traffic, and I pick up the request that's going between auto processing and the transaction processing service. I get that, and I get your JWT as well. So you implemented auth-C, but I've got your token because you've been sending that in plain text. The next thing I do is send a fake request. The thing I do after that is wire all of the money to my Cayman Islands bank account. Now, a lot of this can be solved by implementing TLS, but TLS, again, it's not that easy. It requires an element of managing keys and managing certificates. You have to implement it right. You've got to get the strengths right. But again, Vault has sort of the capability to do this for us. And we can leverage the PKI secrets backend. We can do things like dynamically generated X509 certificates. We've got the capability of generating those with low TTLs, which means that we can rotate them often. And we've also got the capability of a break glass procedure, so we can completely delete anything in the case of a breach if we need to. So let's have a quick look. God, this demo just fills me full of dread. A quick look at that. So again, enable the PKI secrets backend. Next thing I need to do is I'm going to set a lease time. So I'm going to tune the backend. So I'm going to set a maximum lease time of 8,000 hours. And then what I need to do is to either load a sort of an intermediate certificate if you've got your own root, or I can ask Vault to generate a root for me. I'm going to ask Vault to generate a root for me because I'm going to cut a few corners, but realistically, you don't want to keep your root certificates in Vault. Keep them outside and put the intermediate into Vault. So that's going to spit out the certificate and the key. We can ignore that. We don't actually need to save it anywhere. When we start looking at policy, you've got the concept of policy. With the dynamic secrets engine like this one, we've also got to introduce another concept, which is roles. So in order to access and generate certificates, I've got to generate a role. If I could spell. So I'm going to generate a role. I'm going to state that you're allowed to generate subdomains of the certificate, and you're allowed, the domain allowed is just going to be local. So you can set this to anything you want. It's just a standard X509. And the max TTL on a generated certificate is going to be 72 hours. And then what I can do is I can just go ahead and request I generate a certificate. So I'm going to ask for a common name of Gofba. Gopher.local, and I'm going to set an IP sans as well on that certificate. And what Vault does is Vault will go ahead and it will generate the X509 certificate, it'll generate me the private key, and it'll also give me the CA bundle in case I need it, which I most likely will. Now, in terms of how you would use that, since my demo's on the blink a little bit, I can show you how you would use it. And it's actually fairly straightforward. So in terms of use, one of the things that we use is console template. And the interesting thing about console template, this really, okay, so I'm not going to show you that either. So the interesting thing about using console template is that you've got the capability to interact with Vault. Console template will automatically deal with any of the things where you're trying to renew a certificate, when you need to, the lease is coming up and things like that. It's a really useful tool, and it gives you a templating language so you can just interact with Vault and spit these certificates out onto environment variables into memory, however you want to put them inside your container. And dynamic secrets. So I'm still on the theme of secrets, but dynamic secrets is a big problem. So in AWS credentials, there was a recent report came out like a couple of weeks ago. Somebody said that it can take 30 minutes for an AWS credential to be committed to GitHub for somebody to use it. And the researchers behind this actually set up a honeypot. So they deliberately committed AWS creds to Git, and they monitored them. So if you're not rotating your AWS credentials, if you're using credentials which have got higher permissions than they need to, then mistakes are human. I mean, I've done it. I've committed credentials to GitHub. And again, back to this thing. Now, it might not be the credentials that are committed to GitHub that do the damage, but it could be contributing. It's about that factor of elements. Not again. So I had a really nice little demo where I was going to show you I was generating, securing my application and setting up database credentials and TLS credentials, and we don't have any of that. So I'm going to show you again in the CLI. So what I'm going to do is I'm going to enable dynamic secrets, and I'm not going to create them for AWS or GCP, which you can do. I'm just going to use database credentials. So like everything, Vault enable database. And then what we need to do is we need to set up the plugin. So we need to tell the dynamic secrets engine some information. So damn it. So I'm going to set up the config. So what I'm going to do is I'm going to store the root credentials into Vault. And then Vault is going to dynamically generate me application credentials or user credentials based on this information. So like the way that we did it with setting up a role for PKI, we've also got to set up a role for database. So what we're doing when we're setting up the role for the database is that we've got the capability to define multiple roles. So I can set different permissions to different tables. So I can actually dynamically generate credentials with different permissions for different use cases, which is quite nice. Again, I'm setting a TTL. So in this instance, the default TTL on these credentials is an hour. So if I don't renew them, then they'll automatically be revoked. Vault will go back to the database and it will delete the user. Within 24 hours, it's no longer possible to renew them anymore. That's a hard stop on those credentials. These values are 100% configurable. And then likewise, to get those credentials, I can just do Vault read. And you can see what Vault's done there is it's given me a username and a password for my Postgres database. So again, think about this using it through console template. Your applications, you're providing this configuration dynamically. You're using short TTLs because you're accepting the fact that you're going to roll your applications. You're going to keep things short. So if those credentials accidentally leak, hopefully by the time they do leak, they've already been removed. So I can't help you too much with these areas. But again, we can look at the transit secrets engine. So the areas of risk is according to OWASP. You've got things like RPC, message queues, caches, and data serialization. RPC, so you're thinking about object deserialization. You could potentially use message signing if you wanted to. Message queues, you can definitely sign your messages on your message queues. Caches, if you're storing objects on caches and then retrieving them, is it possible for an attacker to change that object or replace it, and then when obviously the application reads it, it has an unintended consequence? Again, potentially looking at message signing. And this is kind of the approach that I'm thinking. So again, you've got this hostile actor, and the hostile actor makes an attack on a random service. But what that gives them is access to a node. Now, whereas in the previous example, you had a direct link between auto processing and transaction processing, auto processing might not even be in the same region. Auto processing is just putting a message onto a message queue. So the hostile actor creates a fake message. They may be using your leaked AWS credentials that you committed to GitHub because you weren't using dynamic secrets. And then they craft this fake message, and they put it onto the queue. The other application processes it. It hits the banking provider. Banking provider transfers all the funds to my Cayman Islands bank account. And lastly, again, application logging and monitoring covers everything. It covers every element of your application. But one of the things that you could and should be doing is thinking about traceability. So whether that's in regard of in the event of a breach or post-breach, you need to be able to trace the source. So by using things like dynamic secrets, then what you can do is you can trace an individual issuance of a secret to an application instance and potentially trace that back. So you've got the source of where an entry occurred. Vault's got the capability, like everything good citizen, will output all of the actions to a log file. It's obviously not going to put any of the secrets out into the log file, but it's going to put things out in a JSON format. So you can easily ingest it in Elasticsearch, or you can push it out in Logstash, process it with FluentD, anything you want. No. Do you really want to see a log file? I mean, I'll do it. Look, Vault isn't going to magically fix all of your problems, but it's free, it's open source, it's trusted by some huge businesses. So, take a look. I'm genuinely a fan, and I think the features that I've talked about today really don't even scratch the surface. Thank you very much.